Honor. So this will be a review. It'll be on the video. I'm going to just get rid of that because you're the last group that tore pages out. So again, the word bisect just means to split something in half. We did that before when we took a line segment and we said, well, let's find a point on that line that splits it exactly in half. It makes, and using our congruence marks, we can show that it makes that left segment equal to the same length, congruent, whatever word you want to use, to the right segment. Those two smaller segments are congruent. That was what a midpoint did. A bisector is the exact same concept when it comes to line segments. Only difference is it's a line that splits it in half instead of a point. That is the only difference. Now there's going to be more to it.
But just the main difference is point.
Yeah, the only difference is it's a line instead of a point when you're talking about a bisector. Now we can also bisect other things with a line. We can bisect an angle, which is what most of today's lesson is about. But keep in mind that it could go back to midpoints. I have no idea what the district's going to do. Your midterm, 20% of your semester grade, so that's a lot. Not as much as your quarter grades. Each quarter is 40%. So your overall quarter grades make up 80%. Your midterm makes up 20%. It can definitely move you a letter grade. So if you averaged your two quarters together and you had whatever, it's possible that you could go up or down based on your midterm. Sometimes you can't. Sometimes no matter what you get on midterm, your grade is already set because of what you got for your two quarters. Yeah, sometimes if you already have like enough points to where you like you're right in the middle, like you average it together and you had a 3.5, so you're right in the middle between an A and a B. Midterm's probably not going to move you high enough or low enough to change it. I don't even remember. I think that was all we did on that. All right, so let's go into the actual lesson. So on the first page 345 of your book pages. I think I actually already have that in here. So this is, you can go ahead and write that down if you're taking notes in a separate book. We're going to talk about two things regarding, this first part is actually a line segment, but we're going to talk about two things regarding bisectors. First of all, what's called a perpendicular bisector. This only has to do with line segments. There is no perpendicular bisector for angles. So it's a perpendicular bisector. What does that word, so we'll just break it down into what each word means. What does perpendicular mean?
90 degrees.
Yeah, it means 90 degrees, right? All these lines that you see in the bricks, the ones going left and right and the ones going up and down, they're all perpendicular. They are at a right angle to each other. That's what perpendicular means. So when you hear that word perpendicular, you're thinking, okay, there are going to be some right angles involved. What does bisector mean? Yeah, we just said that means to split in two. So what's going to happen is you're going to have a line that goes through another line segment. So I've got this line segment here. Let's get a different color. We have this line segment. Actually, we'll do this line segment here. I'm going to have another line that goes through that at a 90-degree angle, and it's going to go right through the midpoint, basically, of it, because it's going to split it into two equal segments. That's what a perpendicular bisector is. Now, I haven't done a lot of stuff with this in class, what I'm about to do. There are some ISLs that I've assigned, which is not a bad idea to go back and practice a few of those if you get a chance before the midterm. This is called a construction. We're supposed to do this in a whole bunch of different lessons. It just is very time consuming and we're already a week or more behind pace, and this would have, there's just no, I don't know that any teachers, I think one geometry teacher does these, I don't know if anybody else does. This would be how you would create the different geometric shapes and concepts by hand, by like using rulers or compasses or whatever you have available, protractors, to physically create, in this case, a perpendicular bisector. you're gonna, I mean, there is no doubt this will be on the midterm, and we haven't covered it. I'm gonna at least cover this one because this is one of the easier and more common ones that I could see them putting on there, but there are other ones. There's one for an angle bisector also, which is in your book page, I think, as well. We're not gonna cover that one, but if you wanna read through it or do the IXLs, I haven't necessarily assigned all the IXLs, but if you just go into geometry and in IXL and type in construct or just construct, a bunch of them will pop up, and you could look for some that look familiar. It's the last week of the quarter, I don't know the day. It'll be like whatever your first period midterm slot is. I want to say it's the very first midterm. I want to say it's Monday morning. Because I think they go first period in the morning, second period in the afternoon on Monday. And then in between, third period. I think. Third period is not a midterm though, it's just you go to third period.
Yeah, then the next day is.
And then the next day is third and fourth with like fifth period in the middle or something.
Yeah.
All right, so here's what this is explaining. So if you see something like this happens to be the one they choose, hopefully you recognize it. So all their set, has anybody ever seen like this? This was a big deal at one point. Like, don't see any shadows. Or wait, are they visible?
They're coming with us
Visible
Monday.
shadows?
There's like 17 kids
I don't
showering.
know why you need to go immediately to learn that they're going with Monday. Doesn't make sense. All right, so hold on just a second. Let me get through this. No, you need to see this. So, did anybody happen to ever see a story? I mean, it was a news story. Like it was. I laugh because this is how dumb people can be sometimes. And I mean, it was on the news. There were some pretty intelligent people that apparently thought this was like a legitimate thing to cover. There were these big, gigantic, there's actually a movie about it called Signs, a long time ago. There were these big, perfectly formed geometrical shapes in like giant fields where they grow like weed or whatever. So that's exactly what they were, circles and triangles, and they're like, how in the world did this happen? Like, aliens must have done, like, I mean, it wasn't like oh haha news story. It was like an actual news story where and people believed it. Aliens had to have done it. There's no way anybody could do this. They did it by using these kind of concepts, construction, just on a much bigger scale. So in a construction like this, we take a point right here, right? So you have a line, so imagine you have a line segment person. You have to draw that. You put, in the case of a very small one, you would use a compass, or they tell you in the book, put a thumbtack in it and like a string attached to the thumbtack. And then you keep the string really tight and you like draw an arc with the string tight. If you don't know, like drawing all the way around the thumbtack would be a circle, because you would stay the same distance from that thumbtack, and if you kept going around, you'd make a circle. So in this case, you're only making part of a circle. You're making the arc. Then what they're doing on this one, which they don't show, is they're doing the same thing from here. Put a thumbtack here or use a compass. Compass, you know what a compass is. The thing has a really super sharp end, and then like you spread it up and down. The pencil's on the outside. So you put the sharp end here, spread it out, and then you make the other arc. And then you just connect them with a ruler. That will be, and I've actually done this at home. When you guys ask, well, when do you ever use it? I've done this at home, and when I was doing something, I was making something, and I'm like, I need to make sure this is 90 degrees, and that it's in the middle, and I'm like, oh, that's right, we learned that, and we had just learned it. It was kind of funny. So this will make a line that splits the other line exactly in half. Again, we're connecting the 2 points where those arcs met. It'll split the line exactly in half, and it will do that at a right angle. So it creates a perpendicular bisector. So again, if we get lucky, and that's the one you see on the midterm, that one I think is pretty easy to recognize without actually doing it by hand. There's actually one that is you split an angle in half. It's kind of the same thing. You put the compass on one point, on one outside. Yeah, I didn't put that one in here. So you have to imagine an angle. And these 2 points are so you have a compass, you put the pointy in here, and then you spread it out to some distance and you mark here. You then keep it at that same distance, you mark there. So these are the same distance away. Then you do that same thing and you make it a smaller distance and you put an arc here and you put an arc here, and then wherever they meet, that's splits it in half. So kind of the same concept, just with an angle. Again, if you don't follow that, don't worry too much about it. It'll be a multiple choice. They're not going to ask you to create it on the EOC or the midterm. Just you'd have to choose. They might either say, what is the next step in doing the construction? They might say, what steps did we just do? Or they might just ask you, what does this construction mean? What are we creating? Something like that. So it'll be multiple choice. So you can just recognize it. You're in good shape. Oh, so by the way, back to the crazy news story in the field. All somebody did, a farmer, they took a tractor, they stuck a stake, like a big, gigantic stake, took a super long rope, tied the rope to the stake, tied the other end to their tractor, and they just mowed around the stake and made a circle. That's what they did. And then they mowed, in the middle of the circle to clear it out. So yeah, and again, that was a movie. It was an actual news story. It cracks me up what some people believe. All right, so now on to the actual lesson. So in a perpendicular bisector, there are some things, now that we know how to create one, there are some things you have to understand about them. Let me zoom in. There we go. So if we have a perpendicular bisector, so we know that we have a perpendicular bisector. We know that's a perpendicular bisector. What do we know? Let's just review real quick. What makes it a perpendicular bisector? What is that? Just what are the two parts of the word? So we know we have a 90-degree angle, right?
And it's split in two.
And we know this is split in two. So there's actually a way to prove this, which we're going to do really quickly. If I know I have a 90-degree angle here, and I have those sides are equal, right? What else do I know? And ignore this. We don't know this yet. This is what we're kind of proving. What else do I know about that figure that we kind of used when we did proofs? And think of it now as two triangles. I know two triangles. What else do I know about those two triangles?
It's reflected.
We don't know that yet, but that's what we're basically trying to prove. How would we prove that?
The line like splitting them, it's another congruent line.
We know that's congruent, right? It's for what, like if you can imagine cutting along the exact middle of it to make two triangles, that line would be so for this triangle over here, it would be the right side of that triangle. For this triangle over here, it would be the left side. It's going to be the same length across both triangles. It's the same line. It's got to be the same length. So now if we know this is the same length, that's the same length, we know that's a right angle, so we could say a squared, b squared, c squared and solve for that, and we'll get the same number. Or, and that's the way I told the other class, but that's actually a faster way, I didn't even think about it. Side, angle, side already tells us we have congruent triangles. So if we have congruent triangles, anytime we finish the triangle, if we take these points that are at the end, these endpoints, and if we draw a line to finish the third side of the triangle, so again, I'm going to erase everything. So if we know these two sides, we know that. We now know anytime I draw in a third side, so I could draw in a third side up to there, I could draw in a third side lower, but anytime I draw that third side in, it's going to create a congruent triangle because I will still have angle, side, angle. Like that will never change. What's that?
What you drew isn't a triangle, though.
What's three triangles? I'm saying I could pick any one of these. Like imagine that. Just imagine this down here.
Oh, okay.
Like I'm drawing in. What I'm saying is it doesn't matter where I draw the triangle. It will always be two congruent triangles because no matter where I draw it, this side's always going to be congruent, right? So that if I draw it to here, that little side's congruent. So I have angle, side, angle. If I draw it to here, well, that would be congruent. So I'd have angle, side, angle. No matter where I draw it, I'm going to have angle, side, angle. So Here's what this whole thing is saying. And if you don't get all that, not a huge deal.
Are all perpendicular bisectors?
Well, the perpendicular bisector is a line that goes on forever. I'm not exactly sure where you're at. So here, I'm going to tell you what you need to know, and then if you still have a question.
No, that's not.
So here's, oh my goodness, she got all fired up. So if I have a perpendicular bisector, this is the concept you need to know. The congruent triangles is why it works. If you don't understand what I just went over, don't worry about it. You're just going to have to memorize more stuff. Like I said, sometimes understanding, well, always understanding the concept helps you not have to memorize so much stuff. If you don't understand the concept, you can get away with it a lot of times. You just got to memorize some stuff. This is one where you can either understand or memorize. If I have a perpendicular bisector, I know that CD is a perpendicular bisector. And it bisects segment AB. I know that. So it bisects. The way that would be written, by the way, because you will see a lot of notation. CD, actually I should have probably said it. Think of that. That's how they will write it. You need to understand this symbol means perpendicular. What symbol, just as a review, means parallel? Well, two lines straight up and down. So like they would write line R is parallel to line S like that. That's what that would be. So you need to understand that because that's how the district's going to do it. They're not going to put it in words, I would guess, when they ask questions. So if I have a perpendicular bisector, any point on that perpendicular bisector will be the same distance from both endpoints. So if I put a point here, it's going to be the same distance from A, that's what that means, as it is from B. That's why those lines are congruent. A point on a perpendicular bisector will always be the same distance from the two endpoints. So if this point is in the middle, because it's a bisector, every point on that is in the middle, basically. So that's the concept. That's how you would be given problems. They'll put a point somewhere on there, and then they'll draw two lines out. They won't put congruence marks in there. They'll just tell you it's a perpendicular bisector. You have to know that those two lines are congruent. And then from there, once you make that connection, there'll be some kind of problem you would be able to set up and solve. So the opposite, the converse, is also true. If I know that all of the points are equidistant, so let's say they gave us this figure. So they didn't tell me anything about this line. It's not in the right spot, but that's fine. They didn't tell me anything about that line. They didn't tell me it's a perpendicular bisector. I drew it too fast. All right, just imagine that line's right down the middle. They don't tell me that, but they do tell me this is true. They tell me these two, so this point is the same distance away from here as this point is, so that distance is the same. This point is the same distance from both endpoints as this point. That means that the line going down the middle is a perpendicular bisector. So what you would need to connect is, well, that means that has to be a perpendicular bisector, which means that has to be 90 degrees. So that could come into play, and then you might have to do like a squared, b squared, c squared, or knowing this is 90 degrees might allow you to solve for an angle or something like that. So again, it's just the reverse of what we just did. All right? So that's perpendicular bisector, which again, only has to do with line segments, perpendicular bisector. Now we're going to do angle bisectors, but it's really the same exact thing. Let me zoom out though. One more time. Oh, there. That should be good, I think. Okay. So if we have an angle, so there's an angle. If I tell, let's do a quick review because I already told you this, but I got this question a lot on the quiz. And I was kind of surprised I got it a lot, especially from this class. How would we say that? Thing in yellow. Angle what?
Angle beats.
Angle, say it. I still haven't heard the right one.
DB.
Yeah, I can say it a couple of ways, but one way would be angle DBE. Again, I had that on a quiz and I said, hey, what's the way you would read it should have been, what is the measure of angle, it was ABC or ACB or something like that. And I got that question all day long, several times in this one class, because we didn't even know what I was asking. So that means angle DBE. Now, if I tell you, well, I'll tell you what they tell you. I tell you that ray, so this is a ray when one is an endpoint and one goes on forever. Ray BF bisects angle DBE. What does that mean? So what does it mean? What's equal? Specifically. Not the sides. It bisects the angle. So what does it mean? That's what I wanted to hear. Angle DBF, use your words, is congruent to, or we could also say equals if we're talking about numbers, angle FBE. That's what it means. So again, if you get that concept, and now I give you some numbers, you should be able to give me number answers. For example, I want to know what is the measure of angle FBE. Don't say it out loud. Figure it out. That's what I want to know. Oh yeah, you will need a calculator for the quiz, so if there's one around, you might as well grab one. Because there's like 4 of them. Oh, you have one? Well, I can't give you one. 4 of them maybe, I want. Anybody else need a calculator? One back there. Everybody have one? All right, so you should have an answer. That's a super easy one. It will not be that easy on the quiz. So yeah, so what's the concept? If we know BF is a bisector, we know that the 2 angles have to be equal. So what does that mean we have to do to figure what they are? Yeah, we just split it in half. So the equation, if you really wanted to get specific, would be, and I'm not going to use all the perfectly correct notation, but that's fine. FBE, so the measure of DBF plus the measure of FBE has to equal 40. So this is actually more of a proof. But what do we know about DBF and FBE? They have to be the same number, right? I'm going to switch to a variable now, so we know they have to be the same number. So x plus x would have to equal 40. Now we can solve. Anytime you have only one variable in an equation, you can solve. So x would have to be 20. What if the algebra got a little trickier and I did this? Still, I'll use the same. Actually, I'm going to make it a little tougher. The other class has got an easier problem. You're going to get her problem. I know, right? Oh, no. Because I want you guys to be challenged. Let's see. What's that? I want you to tell me, what is x? I know, now I've got real. Just got at least you should, at the very least, you should be able to set up the equation for that. The algebra is a little trickier, but again, you should know how to do algebra, you're in geometry. You can't see all, oh, actually, I don't, can I zoom in? Stop breaking my stuff. there. So if you couldn't see the numbers as well, now hopefully you can. Some people are. I've had kids go through like an entire quarter or even a semester sitting in the back, and they, well, actually, I did used to put kids in seats. They would never mention it, but they're like, yeah, I can't see the board. Why didn't you explain that? First piece of that. I think it was in there. I haven't done it yet. Let's see, I'll do it. What did you have? Oh, no. What did you have?
2.5.
Oh, okay. I thought you did. Yeah, I think that's right. Bruh. Raise your hand if you think you got that. Raise your hand if you at least think you just set up the equation correctly.
I think
Alright, again, setting up an equation correctly in geometry gets you a C, so. Alright, what's the concept? So I'm telling you, it's that FB is, or BF is still a bisector. So what do we know about this figure?
if BF is for x, then FB has to be for x as well.
Yeah, we know if it's a bisector that we have to fill that in.
Then after that,
And that's the step I think you missed, Dylan.
Yeah.
And then now we know what else is true.
4x plus 4x is equal to 10x minus 5.
Well, not equals. You said 4x equals 4x.
4x plus 4x.
Yeah, we know this is back to little plus little equals big. We know these two angles added together have to be that big angle, right? That's just the little plus little, the angle addition postulate we learned, it was the name later, but just little plus little has to equal big. So we can say, okay, well, if I know that the big is this, so the big is the 10x subtract 5. That's one little, that's the other little. So that should have been your equation. And then now when you have variables on both sides, it is a little trickier. You got to think about getting rid of them on one side. If you get rid of the 10x, that works. And then you don't have to do as many steps, but you're going to have some negatives. I would always combine like terms first. So you can say that's 8x. So right now, I could subtract 10x, and then I'd have negative 2x equals negative 5. You just divide by negative 2. Or if you don't want to deal with negatives, you could subtract, actually you could add 5 to get rid of that. Subtract 8x, and now you have positive 2x equals positive 5. Again, same number, you get 2.5, 2.5. Remember, after you solve for a variable, what should you do?
Look at the question.
Yeah, look at the question, because I might have asked, did they ask you? Oh, no, this was not a question. I might have asked, what's the measure of angle DBF? So if you just solve for x and quit, you would have gotten it wrong. You would then have to plug that back in and solve out for what the measure was. So 2.5 times 4, you would say is none, which wouldn't make sense for this problem, but just make sure you read the question and see if you're just solving for a variable or if you need to do something else. All right. Let me just make sure before I start doing a review. That was it. Oh, and then the converse is also true. If they don't tell me that's a bisector, but they do tell me that that point F is the same distance away from the two, then that means it has to be a bisector. Yeah. I guess I didn't even say that. If you have a point, kind of like when we just did the perpendicular bisector, any point on an angle bisector is also going to be the same distance away from the two sides. Kind of like any point on the perpendicular bisector is the same distance from the two endpoints. Same concept. And we measure distance, remember, at a right angle. That's why you draw the right angles. That's why those are in there. So points on a bisector are the same distance away from the two sides, the two endpoints, whatever. Opposite is true. If you know that the points are the same distance away, then you know BF has to be a perpendicular bisector. I'm sorry, an angle bisector. That's the only way that can happen. It goes back to really quickly, I'm not going to necessarily maybe solve all this out. Try to set the equation up for that. And I mean, we really just did that. Tell you what, we're going to skip that. You can try that one on your own, example 1. We pretty much just did something like that. It's telling you that RT is the angle bisector. So if we know that's a bisector, we know what? What's the concept we need to do? The angles are split, but we don't really have any angle measures, right? Are these about angles? Are these about angles? There's no degrees, right? They're about, well, they're about length, and in this case, the length of these lines. And we know what about those two lines?
They're equal.
Yeah, they're equal because if this is a bisector, that point is the same distance away from both lines. Last thing I'll say, and then we'll review. I still, and I forget every year that there are kids confused about this. I still have kids that are confused about how can those be the same? That's got like a 4x and a plus 8, and this has like a 9x and a subtract 7. How can those be the same? They're just a number. Again, I'll do this 2 ways. One, we can all have $20. I've said this many times. We can all have $20 and we can have it in 20 different ways or whatever, however many people we have in here. We could have 2 10s, 4 5s, 2 5s, and a 10. It's still all $20. It just looks different. Don't freak out when you see a whole bunch of stuff that's different here and different here, but I'm telling you that they're the same. They are the same final number. I don't know what x actually equals in that, but I could start with x, so tell you what, we'll just ignore those. I could start with x, right? And let's say x is 2. So x is 2. I'm going to say, okay, well, I'm going to multiply 3 times 2. This is not this problem, so not that. I'm just showing you that don't worry about how things look. So 3x plus 4, and x is 2. All right, well, 3 times 2 plus 4 equals, is that 10, right?
Yes.
So now let's say x is still 2. So I'm going to have a different equation where x is 2. 7x subtract 4. So again, doesn't look, it does have a 4, but yeah, let's not do that. Let's make it look totally different. I keep messing up. Randomly choosing. So let's see there. That looks totally different. And then again, x is still 2, right? X has to still be 2. X is always the same number. But that looks totally different, right? They don't look the same at all. But if I plug in 2, I still get 10. It's still the same number. So don't worry about how things look when you are given little expressions like that. It's the same number. You will eventually get to the same number. That's what allows us to solve, is that x has to be the same number, and those two things have to be equal. All right, so with that in mind, a quick review. I wouldn't worry about taking notes. I already have stuff. I guess I'll just use this page. So on the quiz. Oh, what? I better go get this. All right. It's not that I'm not happy to see you. We're like ready to start.
I know.
Oh, is that so? All right. So on the quiz. Which starts out with isosceles and equilateral. So what's true about isosceles? So if you know 2 sides are equal, you know 2 angles are equal. The opposite is true. If you know the 2 angles are equal, you know the 2 sides are equal. That's the connection you need to make. Then, once you've made that connection, you may need to fill in some data. That would then allow you to set up the equation and solve it. What is true about equilateral triangles? All sides are equal. If you know all sides are equal, then all the angles are equal. Or if you know all the angles are equal, all the sides are equal. What's in one additional piece you know about equilateral?
All angles are 60.
Yeah, because all of the angles have to be the same number, which is not true over here. You know that and they have to add up to 180. You know every angle, every individual angle of an equilateral has to be 60. Again, you get the same answer no matter what. It'll just maybe save you a little bit of math and a little time. I think that's all that I'm going to tell you.
Okay.
So let's see. What? Shoot. All right, so if I get, so here's the tricky, so there are 2 pages. Each page is a gradient. So if you're like working on one side and you're like, I'm killing this side, but then you get to the other side and you're like, oh boy, I don't know about this side, then you should have 1 good grade at least. So I didn't like put some questions from 1 grade on one side and the other side. So if I have an X and a Y axis, and I draw in a triangle. So this is the conceptual stuff that I would say is a little trickier. Maybe not for everybody. What do I automatically, I've given you nothing else yet. What do I automatically know about this? You should be able to tell me something already.
It has to.
More than that. Again.
One side.
Yeah, A and C you can figure out.
Figure what out?
The length.
Yeah, the length for A and C.
Not exactly.
Oh wait, A is on 0, 0.
So I know some of the values for the x's or y's, right? For A, I'm on 0, 0. If that's the y-axis, that's the x-axis over here. So that just means that's the x-axis. It's not a point or anything. C is the name of the point. I know A is at 0, 0. There's no way it's not. Like, if I'm putting it on the origin, it's 0, 0. Like, I know the numbers for that, even though I have nothing on the number line. I haven't written a single other number. Didn't even write 0, really. But I know that's 0, 0. What else do I know?
You know your X for C. Your C is
Not the X.
the Y.
I know if I am here, right? I don't know my X because I moved on the X-axis. Like, I did move. There's some value there. But I have no idea how to know what that is. I do know what my Y is, though, because I haven't gone up or down. And if I haven't gone up or down, then I know my Y is 0. Now, let's say we know this is true. I know that's true. And then I give you this. It's not a perfect image, but so I give you that. So we know these 2 angles would be congruent. What else do we know? So what else do we know having to do with the right angle? We could say that this triangle would have a squared, b squared, c squared. What else? Specifically, right where that right angle is. Well, that's a right angle. So we know they're both 90 degrees. But what else do we know? What's the big one that really allows us to do something? We said it earlier today.
The line down the middle.
So the line, now we're getting closer. The line down the middle is the same line, right? It's the same thing. So it's congruent. So what's true then? I guess you got to go now because you got to be here for quiz. But again, you're missing the review that's telling you what's on the quiz. So what do we know? Say it again. Somebody just said it. So we have 2 congruent triangles. So everything's equal, right? In every triangle, the two bottom sides are equal, the two outside sides are equal, the line down the middle is clearly equal. So those are congruent triangles. So because they're congruent triangles, now if I give you some information and I say that is 10b, and I tell you there's a point here, what else can you figure or fill out in that figure?
5b for x.
And then 0, 0, 1.
So for this point here, right, I could say, well, if I know these are congruent, which I do, I know the whole distance is 10b, that has to be a midpoint. That has to be half of that. I also know I'm not going up or down again, just like I didn't on those. So I know that. And what else do I know?
X is also 5b.
Yeah, if this is 5b and that's a perpendicular bisector, then that is all. Now, I do not know the y up there. I haven't given you any information for y. So that would be one that would be given in the problem already. It would already be there for you. It's some number. I don't know. Just like a variable in a problem. Just like when we just did 9x. Hmm? No, b.
But why?
No, they'll just, again, sometimes, here's why they do that. You kids are so used to just plugging stuff into calculators and solving for stuff. And they don't want you just plugging stuff in and solving. They want you thinking about things. So there are a lot, you're gonna see this, I think, I could be wrong, on the midterm and the EOC, you're gonna see a lot, and even you'll notice on a lot of the module tests you've been taking when we go to the computer lab, it's not always just solving stuff. There is definitely some solving, but sometimes it's more conceptual stuff where you're just, you can't solve and come up with a value. I think the EOC will be even more like that because the district doesn't make that up, or maybe not. But yeah, they don't want you to be able to just plug in and solve because you might guess correctly. You might guess, oh, maybe I need to make these equal and solve. You didn't really understand why, but you just said, oh, that I have a variable here that's the same as the variable here. I'm just going to set an equal and solve. So kids can get luckier that way than if you have to truly understand it and come up with something like that. All right, that's your review. So you can put all your stuff up. You actually have more time than the other classes. Is there something? Let me just make sure I didn't forget anything on the review.
This went last today.
I don't believe I did forget anything. Yeah. I don't know why you have a little more time. I felt like we were going slower.
Because there were announcements before.
They were actually, you're right. Yesterday they were long announcements. You are correct about that. Let's see. Where are your quizzes? They're around. They are around somewhere. Oh. There we go. I had so many of these left. Oh, fifth grade. You.
Oh, great.
And then I get another
You.
test.
And I'm going you. Put the phones up. I don't see phones up in the quiz. I have had a lot of issues with kids this year doing things that are very suspicious on quizzes. So I'm going to start cracking down on any phones being anywhere around, like having a phone out, looking at a phone during the quiz, doing other things during the quiz. Yeah, so again,
That's why you don't want to.
I have a phone, look at a phone during the quiz. And I mean, not just like glancing at it, like staring it down for a while. Well, definitely turned out to be some for at least one, they were clearly.
I love my mother.
And then others, I guess. One, yeah.
I thought I did good on the list. I thought I stayed wrong. I got 100 and a 90. Yeah, look at you. I wasn't doing wrong.
You're just trying to rub it in.
Yeah, she was raised at like 6%. Mine went down to 6%.
Guys, my birthday's tomorrow.
Nope. No such thing.
Can I borrow your,
I
Mr. Can I use your pencil check?
They're on my desk.
Give it back. So I get it.
I'll try to.
I want you around there. I want you over there.
Perfect.
Actually, you could just move over. Show how you want to Yeah, I want you farther away. Yep. Yup. You got that right. I guess it doesn't really matter which one you get, so we'll give you this one. Do me a favor and do me a favor and speed up. Future desk, where you should be in line with the third line. Should be these two and then these two, and then you should be in line with that one. So there should be up a little bit, but that's fine for them. When I hand the quizzes out, the desks are in line. I'm not gonna, time is not, and you actually have more time in the other classes, but time hasn't been an issue, so I'll just let you know as we get closer if we're still working what time it is. Right. Five-year-old is still here. Definitely graduated.
Oh, I can do attendance.